A union A, union of a set and the same set is always equal to A itself. A union A is always equal to A. Venn diagram is nothing but diagrammatic representation of a sets, and the properties of sets is called as Venn diagram. The intersection of these two sets is denoted as P intersection Q is equal to set of all elements which are in both A and B. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. Today in this session, I am going to discuss regarding the operations on set as well as the Venn diagram, very important concept. Now, you might have been studied regarding operations on set in your previous class. Let us recall all the operations which you have done in previous classes. Now, let me know the first one, union of sets. In operations on set, let us know regarding union. As you know, union means combining all the elements. Union, combining all the elements of the set is called the union. That is, how to define? Let A and B are any two sets. A and B are any two sets. Then the union of A and B is denoted as A union B. Suppose if A and B are any two sets, then the union of A and B is denoted as A union B, and is defined as the set of all those elements which are in A or in B or in both. The elements which are in A or in B or in both. Now, that is nothing but A and B are any two elements of the set. Then A union of B is denoted as all the elements which are X belongs to A, all the elements which belongs to A, or all the elements which belongs to B. All, that is X such that, here X such that X belongs to A or X belongs to B. A union B. Let us take a simple example. Let A is equal to A, B, C, B is equal to C, D, E, F. Then the union of these two is denoted as A union B is nothing but, just write down A first. A contains A, B, C, and B contains C, already we have taken D, E, F. So, A, B, C and D, E, F comes under A union B. Now, let us take one more example. If A is equal to 1, 2, 3, 4, 5, B is equal to 1, 2, 3 up to 9, then A union B is equal to same 1, 2, 3, 4, 5, 6, 7, 8, etc. up to 9. This is nothing but union. That means all the elements which belongs to A or B. Now, let us take one more example. If A is equal to 2, 4, 6, 8 and B is equal to 1, 3, 5, 7, 9, then the union of these two is denoted as A union B is equal to, write down all the elements. So, let us take 1, put it in order, 1, 2, 3, again 4, again 5, 6, 7, 8 and 9. All the elements comes under the union of these two sets, A union B, X such that X belongs to A or X belongs to B. Now, let us come to the second one. Let us know some properties regarding this union of sets. A union A, union of a set and the same set is always equal to A itself. A union A is always equal to A. So, A union A, the set and the union of the same set is always equal to A. A union null set, the union of a set and a null set is also equal to the same set. And if we come to the intersection, the next concept we are going to study regarding the intersection of set. A and A intersection, a set and a null set intersection is a null set. Suppose if A is a subset of B, then A union B is equal to B. Now, proper subset, if A union B is equal, if A is a subset of B, then A union B is also equal to B. Now, before that, let us know regarding the intersection of the sets. So, what is intersection of set? So, let A and B are any two sets, then the intersection of A and B is denoted as A intersection B, reverse U, A intersection B, and is defined to be the set of all common elements between A and B. So, that is if A and B are any two elements, the intersection of these two sets is denoted as A intersection B is equal to X such that X belongs to A and X belongs to B. All the elements which belongs to A and B, that is nothing but the common elements. All the common elements in A and B will comes under a set that is called the intersection of sets. Now, let us take an example. If A is equal to, let A is equal to A, B, C, D, B is equal to C, D, E, F, then the intersection, what are the common elements? So here we have C, we can take C, and D. C and D are the common elements. So A intersection B is equal to C comma D. Whereas A is in set A is not in B, we cannot take, and B is in set B, it is not in B, we cannot take. Whereas E, F, G are the elements in set B, but they are not in the set A, therefore we cannot take E, F and G. So only the common elements are C and D. These two elements we can take as a intersection. A intersection C is equal to the common elements C and D. Let me take one more example. Let A is equal to 1, 2, 3, 4, 5 and same B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the intersection of these two sets is A intersection B is equal to 1, 2, 3, 4, 5. That's all. That is equal to A itself, because A is a subset of B. So if A is a subset of B, then A union, then A intersection B, here this is A intersection B is equal to A, right. So here let A is equal to 1, 2, 3, 4, 5 and B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Then intersection of these two set is nothing but the set A itself, 1, 2, 3, 4, 5, because all the elements of A are all the elements of B. Now let me take one more example. If P is equal to 1, 2, 3, 4, 5, 6, another set Q is equal to 2, 4, 6, 8, then the intersection of these two sets is denoted as P intersection Q is equal to set of all elements which are in both A and B. Now P contains 1, Q does not contains 1, we cannot take 2. 2 is in both A, P and Q. 2 belongs to both P as well as Q. 3 is not there, we can take 4. 4 is in set A as well as in set B. And again 6 is in set A and set B, but 8 is in set B but not in A. So therefore P intersection Q is equal to 2, 4 and 6. This is called the intersection of two sets. Now A union B, set of all the elements which are in A and which are A or in B, A union B. Whereas intersection of sets means set of all the elements which are in A and B, that is the common elements. Now let us come to the next one. So therefore union of a set and the union of a null set is a set itself. A set and the intersection of a null set is a null set. Let me take an example. Here suppose if A is equal to 1, 2, 3, another set A is also equal to 1, 2, 3, then what is the union of A and A? A union A is equal to 1, 2, 3 itself. So A union A is equal to A, right. Now if we come to the second part, if let us consider B is a null set, then A union B, that is nothing but A, what is A contains 1, 2 and 3 union null set. So A union null set is nothing but the same set itself, 1, 2 and 3, you will get the same set. So union of a set and a null set is same set. Whereas if you come to the same set, A is equal to 1, 2, 3 and B is equal to a null set, then the intersection A intersection B, what are the common element in these two? There are no common element, therefore intersection of a set and a null set is always equal to a null set, right. If A is a subset of B, then A union B is always equal to B, right. A union B is equal to B, okay, right. Now let us come to the next concept, that is difference of any two sets. Difference of two sets is nothing but A minus B and B minus A. So let A and B are any two non-empty sets, then the difference of two sets A and B is denoted as A minus B is defined to be the set of all those elements of A which are not in B. That means A minus B means all the elements which are in A but not in B, that is A minus B, that is nothing but X such that X belongs to A and X does not belongs to B. That's all. All the elements which belongs to A and does not belongs to B is called A minus B, that is called A difference B. Similarly, B minus A means X such that X belongs to, yes, all the elements which belongs to B and does not belongs to A. All the elements which belongs to B does not belongs to A is called B minus A. So that is A minus B and B minus A. See, let us consider it is also called as the complement of B with respect to A. Similarly, B minus A is denoted as set of all those elements which are in B but not in A. It is also called as the complement of A and it with respect to B. Now, let us take an example. Now, what is an example? That A is equal to A, B, C, D, B is equal to D, E, F, G, H, I. Now, what is the difference? The difference between A and B, A minus B, all the elements which are in A but not in B, all the elements which are in A but not in B. A is here, that is not in B, so A is in set A but not in B. Similarly, B is in set A but not in B. Then C is not there, then we can take A, B, C. D is common in both the sets, so therefore we cannot take. So A minus B means all the elements which are in A but not in B. So A contains A, B does not contain A. Similarly, the set A contains B, the set B does not contain B. Similarly, the set A contains C, whereas the set B does not contain C. So we can write A, B, C. And this D contains A as well as B, therefore we cannot take. This is A minus B. Similarly, come to B minus C. B minus A means what? All the elements which are in B but not in A. Elements which belongs to B but not A. So D is there, we don't want. Then E is in B but not in A, we can take E. Similarly, F is in B but not in A. Similarly, G is in B but not in A. H and I. So E, F, G, H, I are which are in B but not in A, that is the difference. So the difference, what is the actual meaning of difference? Difference between A and B means the elements which are in A but not in B. Similarly, difference between B and A means B minus A, the elements which are in B but not in A. So what is say from these two? A minus B and B minus A are not equal. A minus B is not equal to B minus A, right? Now let us take one more example. If A is equal to 1, 2, 3, 4. Another set B is equal to 3, 4, 5, 6 and 7. Now let us write the difference of these two sets. What is A minus B? A minus B is nothing but all the elements which are in A but not in B. Elements which are in A is 1, not in B. Element which are in A is 2, not in B. And 3, 4 are common, we don't want. So A minus B is 1, 2. Elements which are in A are 1 and 2, they are not in B. Similarly, to second one, B minus A. B minus A means elements which are in B but not in A. So 3 and 4 are there. So 5 is in B, 6 is in B, 7 is also in B but not in A. So A minus B is equal to 1, 2, B minus A is equal to 5, 7 and 6. This is called the difference. So here also A minus B is not equal to B minus A. Let us discuss regarding the complement of a set with respect to universal set. Suppose if U is a universal set, it is a superset. So let A be a set, then the complement of a set A with respect to U is a universal set, is the set of all elements which are in U but not in A, denoted as U minus A or A dash or AC. So A complement is A dash or AC is a set which are in U but not in A. Now let us take one example. If U is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. Now let us consider two sets. A is equal to 0, 1, 2, 3. Another set B is equal to 5, 6, 7, 8. Then the complement of these two is nothing but A dash. A dash is equal to U minus A. The complement of A is A dash is U minus A. That means all the elements which are in U but not in A. So in U we have 0, 1, 2 and 3. These three elements are not in A. Therefore we can take 4, 5, 6, 7, 8 which comes under A dash. The complement of A. Similarly, what is the complement of B? B dash or BC. BC or B complement is nothing but U minus B. What is U minus B? Elements which are in U but not in B. So here we have 0 not in B, again 1 which is in set U but not in B, 2 and 3 are in B, 0, 1, 2, 3 and 4 up to 4. See here 0, 1, 2, 3, 4 which are in A, U, these are in U but not in B. So therefore the complement of B is B dash is equal to 0, 1, 2 and 3. Okay, this is the complement. Let us come to the next concept, Venn diagram. So this is very important concept. You may expect one question from this. Now, what is Venn diagram? Venn diagram is nothing but diagrammatic representation of a sets, and the properties of sets is called as Venn diagram. The pictorial representation, diagrammatic representation of the sets and the properties of sets, the elements of the set and the properties of the sets is called as a Venn diagram. The pictorial representation or diagrammatic representation of the properties of a set or the elements of a set is called as the Venn diagram. So usually in Venn diagram we are going to consider a rectangle and a circle or a oval shaped figure. So a rectangle, circle or a oval shaped curve. So a set is represented by a circle as a closed figure, a circle or a closed figure like A and B. So while constructing a Venn diagram, we are going to consider a circle or a oval shaped curve or a rectangle. So these are the diagram which usually we will use to construct or to solve the problems using Venn diagram. So a set is represented by a circle or a closed figure, circle or a closed figure. Now like this. Now let us come to the one by one. First one, universal set. Now the first one itself is a set. A set is represented by a circle or a closed figure like this. Now universal set, second universal set is U. U is represented by a rectangle. So a rectangle will represent the universal set. Now next, the union of sets. This is very important. So union of sets can be diagrammatically represented as, if A and B are any two non-empty sets, then the union, the all elements which comes under A and B is represented like that, is called as union. The shaded portion is called the union of set. Let me take an example. If A is equal to 1, 2, 3, 4 and B is equal to 3, 4, 5, 6, then how to write the union of these two sets? So the union of these two sets is, write down set A and set B. What are the common elements in set A and set B? 3, 4. So these 3 and 4 are the common. So what A contains? A contains 1, 2, 3, 4. B contains 3, 4, 5, 6. This is called the union of two sets A and B. So write down the common elements, then all the elements which are in A. So therefore A contains 1, 2, 3, 4. All the elements which are in B, B contains 3, 4, 5, 6 including the common elements. This is how we are going to represent A union B using Venn diagram. Now let us come to the second one, intersection of two sets. The intersection of two sets. Suppose if A and B are any two non-empty sets, then the intersection of two sets will give the shaded region. This shaded region will give the intersection of the two sets. That means common elements which are common in A and B is called the intersection. Let us denote it as A intersection B. Let us consider an example. A is equal to 1, 2, 3, 4, 5. Another set B is equal to 4, 5, 6, 7. Then what is A intersection B? Here the A intersection B is denoted as the common elements. What are the common elements? 4 and 5. This is called the intersection of A and B. This is A intersection B, the common element. Let me take one more example. If P is equal to A, B, C, D, E, another set Q is equal to C, D, E and F, then the intersection of these two is denoted as, these are the two sets, only the common elements. What are the common elements? We have C, D and E. C, D and E. This is called the intersection, A intersection B. C, D, E. And the remaining elements, A and B comes here, A, B, C, D, E, and this E already there, we can write F for this. So this is how we are going to represent A intersection B in a Venn diagram. Now next, the difference between the two sets A minus B. As you know, the difference between A and B is the set of all elements which are in A but not in B. So all the elements which are in A but not in B is denoted by this shaded region. So all the elements which are in A but not in B. Now the shaded portion will give us the difference between the two sets A and B, that is A minus B. Now let us take one more example. If A is equal to 1, 2, 3, 4 and 5, another set B is equal to 3, 4, 5, 6, 7. Then how to represent the difference A minus B? So here this is set A and set B. This is A and B. The difference between these two is nothing but set of all elements which are in A but not in B. So common element, what are the common elements we have? 3, 4 and 5, right. So only the elements which are in A, all the elements which are in A is 1 and 2. 1, 2, 3, 4, 5 are common, we cannot take. So these elements 1 and 2, this will represents the difference. So this is called A minus B, elements which are in A but not in B. This portion, the portion 1, 2 containing the difference of A and B. Now let us come to the second one, B minus A. What is B minus A? The shaded region towards B, elements which are in B but not in A. Let us represent by taking simple example. If A is equal to 1, 2, 3, 4, another set B is equal to 3, 4, 5, 6 and 7. The difference B minus A. What is B minus A here? This is sets. So let us represent this as set A and this as B. Now B minus A, elements which are in B but not in A. What are the common elements? We have 3 and 4 as the common elements. Elements which are in B, 5, we have 5 but not in A. 6, similarly 6 and 7. So these elements, that is 5, 6 and 7, this will give the values of B minus A, elements which are in B but not in A. So that is B minus A. So this is how we are going to represent the elements or the properties of a set in a pictorial diagram, that is called a Venn diagram. Now let me explain one more example. Let us take an example. Let U is equal to, example, let U is equal to 1, 2, 3, 4, 5, 6, 7, 8 and 9, right. U. Let us take A. A is equal to, let A is equal to 2. A is equal to 2, 4, 7, 8 and 9. B is equal to 1, 3, 5, 8 and 9. Now let us represent all the properties in Venn diagram. Now let us write, this is the universal set. U is the universal set. This is A and B. Now let us take the intersection first. What is the intersection B? Intersection B is nothing but the common 2, 4, 7 not there, 8 and 9. 8 and 9 are the common elements. So this is the intersection, A intersection B, right. Now A union B. What is A union B? A union B, elements which are in both A and B. Let us write 2, 4, 7, 8, 9, then 1, 3, 5, right. So write down A union B. So what is A contain? A contains 2, then 4, 7, 8, 9 is already there. Then what is B? B contains 1, 3, 5, 8, 9. So all these comes under A union B. So A union B is equal to all the elements, that is 1, 2, 3, 4, 5, 7, 8, 9. 1, 2, 3, 4, 5, 7, 8, 9. A minus B. Now how to write A union B? What is A minus B then? The difference between these two. From the diagram, how can you write A minus B? A minus B. A minus B means all the elements which are in A but not in B. All the elements which are in A but not in B. That is, all the elements which are in A are 2, then 4 and 7, right. 8 and 9 are there. So this part will give the elements which are in A minus B. This part, all the elements which are in this part will give A minus B. This is A minus B, right. Similarly, what is B minus A from this diagram? B minus A means all the elements which are in this part. So that is 1, 3, 5, 7. 1, 3, 5. That's all. See, what is B minus A from this? B contains 1, it is not there. 1, again 3, then 5, 8 and 9 is there. So this part will represent the B minus A. This is called B minus A. This is A minus B, A intersection B, and A union B. The universal set, since what are the elements left over, then only 6, then so only 6 is left, so we can write 6 here. So all these 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 comes under this universal set. This is how we are going to represent the elements in a Venn diagram. So this pictorial representation is called the Venn diagram. Hope you got an idea regarding how to represent the elements of the set like A union B, A intersection B, A minus B, B minus A in Venn diagrams. That's all regarding today's session. I think you got an idea regarding the Venn diagram. Let us discuss with the application type of problems in Venn diagram in the next session. Thank you very much.